The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. Alrighty, do any of you have any questions over last night's homework before we go on? If so, now is the time to speak. Alrighty, I guess we'll go on then. So we're going to go on to section 6.7, and we've been looking at factoring polynomials, binomials, and trinomials, and etc. And what we're going to look at now is how to solve equations involving these polynomials. And specifically, we're going to talk about solving quadratic equations, which are second-degree equations. That would be the variable in the equation would be, the highest power of it would be a 2. So you'd have like an x squared or something like that. Anyway, but we're going to look at solving equations by factoring. And the first thing I want to talk about is called the zero factor property. I'm trying to remember if this one, yes, this book calls it that, the zero factor property. I've had other names for it as well. So what that amounts to is this. If we have something like a times b equals 0, what could we tell about a or b? Or maybe both of them? Anything?
Leading coefficient is a 1.
True, true. But what about a or b specifically? If a times b equals 0, is there something we could figure out that either a or b would have to equal for this to be true?
One of them are 0. One of them is 0.
Yes. So either, oops, a, can't write with the darn this morning. Either a or b or both would equal 0. Okay. So if we've got a times b equals 0, either a is 0 or b is 0, or they both could be 0. All right. So with that in mind, let's say we've got the following situation. X minus 3 times x minus 2 equals 0. This is in that form, a times b equals 0. So that means either a equals 0 or b equals 0. You see what I did there? So in this situation, a would be that factor x minus 3, b would be that factor x minus 2. If x minus 3 equals 0, x would equal 3. If x minus 2 equals 0, x would equal 2. So for this situation, x could equal 3 or x could equal 2. Any questions about that? All right. Let's take a look at another problem. Let's say we've got x minus 8 times x plus 8 equals 0. Again, this is in that form, a times b equals 0. So we've got x minus 8 equals 0 and x plus 8 equals 0. And then taking each of these first degree equations, notice what we're doing. We're taking a second degree equation. It may not look like it, but if we multiply this together, there'd be an x squared in it. We're taking a second degree equation and breaking it apart into two first degree equations. Solving the x minus 8 equals 0, we'd add 8 to both sides and get x is 8. Solving the x plus 8 equals 0, we'd subtract 8 from both sides and get x equals negative 8. So we get those two solutions. Again, any questions there? All righty. Let's see here. Let's say I've got negative 6t times the quantity 2t minus 9 equals 0. So that means either negative 6t equals 0, or 2t minus 9 equals 0, or perhaps both. So negative 6t equals 0. We divide both sides by negative 6, and t would equal 0. 2t minus 9 equals 0. We'd add 9 to both sides. 2t equals 9. Divide both sides by 2. T equals 9 halves. So t equals 0 and t equals 9 halves. Again, any questions there? All right. Let's say we've got this. We've got m times n plus 1 times n minus 6 equals 0. This is actually a third degree equation. Oh, that's not an m, that's an n. Good thing I've got my glasses on. A lot of good it's doing, huh? Yeah. All right. So I've got 3 factors, each of which could be set equal to 0. So n equals 0, n plus 1 equals 0, n minus 6 equals 0. Well, if n equals 0, then n equals 0. If n plus 1 equals 0, subtracting 1 from both sides, we get n equals negative 1. If n minus 6 equals 0, adding 6 to both sides, we get n equals 6. So this equation is technically a third degree equation, and it has 3 solutions. We good to go? All right. Now, let's say we've got this situation. X squared plus 7x plus 6 equals 0. That is not in the form a times b equals 0, at least not yet. But if we use the tools that we've been learning to factor, the second degree polynomial or the quadratic polynomial on the left side of the equation, let's see what we get. We get x and x. We'd have to have a product that's 6 and a sum that's 7. So 6 and 1 plus 6 plus 1 equals 0. So by factoring that trinomial, now it's in the form a times b equals 0. And then I take this equal to 0 and that equal to 0. If x plus 6 equals 0, subtract 6 from both sides, x equals negative 6. If x plus 1 equals 0, subtract 1 from both sides, x equals negative 1. Let's go ahead and check our work. But first I want to point out this. You see that this is a second degree equation. So it's going to have 2 solutions. All right. Let's take the negative 6 and plug it in. So negative 6 squared plus 7 times negative 6 plus 6 equals 0. So that's going in there. Okay. This would be 36 minus 42 plus 6 equals 0. And we get 0 equals 0. So it checks. 36 plus 6 is 42. Minus 42 is 0. Okay. Let's take the x equals negative 1. Negative 1, the quantity squared, plus 7 times negative 1 plus 6 equals 0. Negative 1, the quantity squared is 1. So we get 1 minus 7 plus 6 equals 0. 0 equals 0. So both the solutions check. Any questions there? All righty, let's take a look at another problem. A squared minus 17a plus 60 equals 0. Now, I want to point out this is a second degree equation that's in standard form. We talked about a trinomial in standard form would be like ax squared plus bx plus c. So a second degree or quadratic equation in standard form would be ax squared plus bx plus c equals 0. Okay, so this is in standard form of a quadratic or second degree equation. All right, now I'm just going to recopy that. We have a trinomial on the left side of the equation, set equal to 0 on the right side. Let's see, it's in standard form. There's no greatest common factor. It's not a perfect square. The leading coefficient is a 1. So we've got a, we've got to have a product that's 60 and a sum that's negative 17. To get a positive product, I've got to have a positive and a positive, or a negative and a negative factors. But to get a negative sum, they'd have to both be negative. So negative 60 and negative 1, negative 30 and negative 2, negative 15 and negative 4. How about negative 12 and negative 5? That would do it, wouldn't it? Yeah. So minus 12 minus 5. So now it's in the form a times b equals 0. So a minus 12 equals 0 and a minus 5 equals 0. If a minus 12 equals 0, we add 12 to both sides. A is 12. If a minus 5 equals 0, we add 5 to both sides. A is 5. So a is 12 and a is 5. All right. Let's take a look at another problem. X squared minus 36 equals 0. This is a quadratic or second degree equation in standard form. There's no bx term, but it's still in standard form. The left side is the difference of two squares. So it would be x plus 6 times x minus 6 equals 0. So then x plus 6 equals 0, x minus 6 equals 0. If x plus 6 equals 0, we subtract 6 from both sides and get x equals negative 6. If x minus 6 equals 0, we add 6 to both sides and get x equals positive 6. So two solutions to a second degree or quadratic equation. All righty, let's see here. How about this one? X squared equals 5x. This is not in standard form. It's not set equal to 0. And for this whole process to work, it has to be one side of the equation equal to 0 on the other side of the equation. So the first thing I'm going to do is put everything on one side of the equation, and I'm going to move everything to the left so that I have a leading coefficient that's a positive 1 rather than putting it on the right and making it a negative 1. X squared minus 5x equals 0. Now, you might look at this and say, well, that's not the difference of two squares, so there's nothing I can do. But there is. Can anybody tell me what we can do with this? The first thing?
Take out the x.
Why? As in WHY. What is that x? What are you taking out? You're taking out the
Variable.
greatest
Common factor.
There you go. There you go.
Yay.
Yeah, okay. Good. So now it's factored completely. So either x equals 0 or x minus 5 equals 0. Okay. It doesn't have to have parentheses around it for it to be a factor. So like this x, it's a factor. Okay. So if x equals 0, well then x equals 0. X minus 5 equals 0. Add 5 to both sides. X equals 5. So x equals 0 and x equals 5. How about this one? 3x squared plus 14x equals negative 8. So the first thing we've got to do here is put it in standard form with 0 on one side of the equation. I'm going to add 8 to both sides of the equation. So I've got 3x squared plus 14x plus 8 equals 0. So now I need to factor the trinomial on the left side of the equation. Let's see. So it is a trinomial. It's in standard form. There's no greatest common factor. It's not a perfect square trinomial. It doesn't have a leading coefficient of a 1. So we're either going to use grouping or trial and check. What would you like me to use?
Grouping.
Grouping, okay. So A is 3, B is 14, C is 8, the product is 24, the sum is 14. How about, let's see, 12 and 2. Okay with that? 12 times 2 is 24. 12 plus 2 is 14. So now I've got 3x squared plus 12x plus 2x plus 8 equals 0. I'm still taking the middle term and splitting it up into two terms whose coefficients are those two numbers. Okay. Factoring by grouping. Greatest common factor, 3x with an x plus 4 left over. So an x plus 4 left over here and a plus 2 outside. So then I've got an x plus 4 times 3x plus 2 equals 0. So now it's factored. A times b equals 0. Take each factor that contains a variable and set it equal to 0. And then solve each of those first degree equations. X plus 4 equals 0. Subtract 4 from both sides. X equals -4. 3x plus 2 equals 0. Subtract 2 from both sides. 3x equals -2. Divide both sides by 3. X equals -2/3. So two solutions to a second degree equation. Any questions there? Do I need to pause for you to get caught up before I go on? All right, well, we'll go on then. Let's see here. 5m times 5m plus 8 equals -16. Now, you might look at this equation and say, oh, the left side is already factored. 5m and 5m plus 8. Great. However, since the right side is not equal to 0, the fact that the left side is factored is not only useless, it's worse than useless, because I've got to multiply it all together and then move the -16, add 16 to both sides, and then pull it all apart. It's the 0 factor property. It's not the -16 factor property. For this to work, it has to be set equal to 0. Okay? So multiplying this together, I get 25m squared plus 40m equals -16. Then I'm going to add 16 to both sides. So 25m squared plus 40m plus 16 equals 0. So now it's in standard form. Now I can get started with the whole factoring process. So on the left side of the equation, I've got a trinomial in standard form. There's no greatest common factor. Oh, it looks like it could be a perfect square. It starts with a square and then plus a square at the end. Let's see if that's going to work. This would be 5m and 5m, 4 and 4. And let's see. Can you mute your microphone? We're getting talking coming through there, Taylor.
Oh, I'm sorry.
That's all right. If you've got something to say, we want to hear it, but not everybody else in the room there. Okay, thanks. So I've got to have a plus sign and a plus sign. That's going to give me 40m in the middle. So that's going to work. Okay. So I've got 5m plus 4 equals 0 and 5m plus 4 equals 0. So subtracting 4, I get 5m equals -4. Divide by 5, I get m equals -4/5. And this one is also going to be the same answer because it had the same equation. And you could write that, or you could say m equals -5/4 repeated. That's what the author of the textbook does. Anyway, so you've got the same solution, but twice. All right. That's always going to happen whenever you've got a perfect square trinomial, because a perfect square trinomial has two identical factors, which would lead to two identical solutions. Okay. Let's see here. How about this one? 3x times 3x plus 10 equals 6x minus 16. So here again, we need to get this in standard form. So I'm going to multiply the left side. We're going to get 9x squared plus 30x equals 6x minus 16. Going to move everything to the left side of the equation. So I'm going to subtract 6x and I'm going to add 16. So I get 9x squared plus what 30x minus 6x is 24x plus 16 equals 0 because everything on the right side cancels. Okay. This also looks to be a perfect square trinomial on the left. 3x and a 4, 3x and a 4, and it would have to be a plus and a plus. That gives us 24x in the middle. So we've got 3x plus 4 equals 0, and the same thing, subtracting 4 from both sides. 3x is negative 4, divide by 3, x is negative 4/3, and this one is also going to be x is negative 4/3. Okay, let's see here. Let's say we've got x cubed minus 7x squared plus 10x equals 0. This is a third degree equation, therefore it has 3 solutions. Let's see, it's already in standard form. On the left side, we could take out a greatest common factor of an x. We could further factor the trinomial. Let's see here. We're going to have what, a minus 5 and a minus 2. We need a product of 10 and a sum of negative 7. So negative 5 and negative 2. So now I've got it factored. So x equals 0. X minus 5 equals 0. X minus 2 equals 0. If x equals 0, then x equals 0. X minus 5 equals 0. Add 5 to both sides. X equals 5. X minus 2 equals 0. Add 2 to both sides. X equals 2. 3 solutions to a third degree equation. Okay, let's see here. 9y squared equals 64. Again, if I'm going too fast, if you need me to leave things up there longer for you to write it down, please let me know. I'm not in any hurry. All right, so here we've got a second degree equation. It's not in standard form. I'm going to move everything to the left side of the equation. I believe that is the difference of 2 squares. 3y plus 8. 3y minus 8. Okay, so 3y plus 8 equals 0, and 3y minus 8 equals 0. Let's see if I can write that a little easier to read. Okay, I'm going to subtract 8 from both sides. 3y equals negative 8, divide by 3. Y equals negative 8/3. 3y minus 8 equals 0. Add 8 to both sides. 3y equals 8. Divide by 3. Y equals 8/3. 8/3. Notice, when your factors are conjugate pairs, your solutions are opposites, aren't they? Negative 8/3 and positive 8/3. Okay. I want to talk about a common mistake that I see students make when it comes to a test. They'll get a problem like this. And the first thing they'll do is multiply it all together. But you don't have to, because this one is factored set equal to 0. If you've got something like this one, where it's factored but not set equal to 0, then yeah, you need to multiply it out, move everything over. But if it's already set equal to 0, we can go right to the finish line and say x plus 2 equals 0, x plus 3 equals 0, x minus 4 equals 0. These were the kinds of problems we looked at first. So here you're going to get x is -2. Here you're going to get x is -3. And here you're going to get x is +4. Okay, so be careful of that, because I'll see this all the time. Students take this and multiply it all out and then turn right around and factor it again. A lot of extra work. Okay, how about this one? 2m squared minus 8m equals 2m minus 12. So I need to get this in standard form. I'm going to subtract 2m from both sides of the equation and add 12 to both sides of the equation. So I get 2m squared minus 8m minus 2m is minus 10m plus 12 equals 0. All right. So now it's in standard form. I'm going to take out the greatest common factor. Let's see, 5m plus 6, okay. And then factor it further. I've got a leading coefficient of a 1. Product is 6, sum is -5. How about -3 and -2? Okay. Now, I've said this, but it didn't necessarily mean anything yet. This is what I've been saying. I've been saying, take each factor that contains a variable and set it equal to 0 and solve it. Well, 2 is a factor of this equation. 2 does not contain a variable. You wouldn't take 2 and set it equal to 0, would you? 2 doesn't equal 0, 2 equals 2. The whole thing is about figuring out what the variables are. So when I say take each factor that contains a variable, that would be this one and this one, but not that one. Well, then what about the 2? What do we do with it? Well, we could do this. We could go back and say, let's divide both sides of the equation by 2, and we'd have that. Or we could just ignore it in the solving process, and that's what I'm doing when I say, take each factor that contains a variable and set it equal to 0. So the 2, I don't need to do anything with it. It's just a 2. So now I've got m minus 3 equals 0, m minus 2 equals 0, add 3 to both sides, m equals 3, add 2 to both sides, m equals 2. Second degree equation, 2 solutions. Okay. Let's see here. How about this one? P times p plus 1 equals 6. So here again, the left side's factored, but so what? It's not set equal to 0. So let's multiply this out and then move the 6 over. Now it's ready to be factored. Let's see, the product is -6 and the sum is 1. How about 3 and -2? Is that going to do it? Plus 3 minus 2. So p plus 3 equals 0. P minus 2 equals 0. Subtract 3. P is -3. Add 2. P is 2. Let's go back and check our work again. I haven't been doing that. I've gotten lazy here. If p is -3, we'd have -3 times -3 plus 1 equals 6. -3 times -2 equals 6. 6 equals 6, so it checks. If p is +2, we'd have 2 times 2 plus 1 equals 6. 2 times 3 equals 6. 6 equals 6, so it checks once again. Okay. Let's see here. How are we doing for time? We got lots of time. M cubed minus 8m squared plus 16m equals 0. This is in standard form. It's a third degree equation. because of m cubed. Let's see, the greatest common factor is an m. We take that out and have m squared minus 8m plus 16 equals 0. Okay. The trinomial in parentheses, it looks like it could be a perfect square. Let's see, a 4 and a 4, but the sign in the middle would have to be minus. Does that give me minus 8m in the middle? It does. So I've got m equals 0, m minus 4 equals 0, m minus 4 equals 0. So m equals 0, add 4 to both sides, m equals 4, and again, m equals 4. Okay, let's see here. How about this one? Negative 8x squared plus 3 minus 10x equals 0. So it's set equal to 0, but it's not quite in standard form. So let's rearrange the terms. Negative 8x squared minus 10x plus 3 equals 0. So now it's in standard form, okay? Now, there's no greatest common factor, but my leading coefficient is negative. So the next thing I'm going to do is factor out a negative 1, which is going to have the effect of changing the sign of each term inside the parentheses, okay? Now, that trinomial inside, I'm going to use grouping on it. A is 8, B is 10, C is negative 3, product is negative 24, and the sum is 10, 12, and negative 2. Okay. So I've got negative 1 times 8x squared plus 12x minus 2x minus 3 equals 0. I'm going to use factoring by grouping. So I've got negative 1 times, let's see, the greatest common factor is 4x with 2x plus 3 left over. So 2x plus 3 left over and a minus 1 outside. So I've got negative 1 times 2x plus 3 times 4x minus 1 equals 0. So now it's factored completely. Take each factor that contains a variable and set it equal to 0 and solve it. So what am I going to do with that negative 1 out front? Just ignore it in this process. I could divide both sides by negative 1 and that would get rid of it. And on the right side, 0 divided by negative 1 is still 0. Or I could just take each factor that contains a variable and set it equal to 0. Okay. So 2x plus 3 equals 0. Subtract 3 from both sides. 2x equals negative 3. Divide by 2. X is negative 3 halves. 4x minus 1 equals 0. 0. Add 1 to both sides. 4x equals 1. Divide by 4. X equals 1/4. And there you have two solutions to a second degree equation. Okay, how about this one? Q squared minus 1/4 equals 0. So here we have a binomial on the left side, but it is set equal to 0. We've got the difference of two squares. So we're going to have Q squared minus, let's see, what do you square to get 1/4? You square a half. A half times a half is a fourth. So we're going to get Q plus 1/2 times Q minus 1/2 equals 0. Take each factor that contains a variable, set it equal to 0, solve it. So Q plus 1/2 equals 0, subtract a half from both sides, Q equals negative 1/2. Q minus 1/2 equals 0, add 1/2 to both sides, Q equals positive 1/2. Okay, let's see here. How about this one? 6n cubed minus 6n equals 0. It's already in standard form, set equal to 0. So on the left side of the equation, I'm going to take out a greatest common factor, which is 6n, leaving me with n squared minus 1. But n squared minus 1 is the difference of 2 squares. So we've got 3 factors containing a variable. After all, it's a third degree equation, so I should come up with 3 solutions. So 6n equals 0, n plus 1 equals 0, n minus 1 equals 0. If 6n equals 0, divide both sides by 6, n equals 0. If n plus 1 equals 0, subtract 1 from both sides, n equals negative 1. If n minus 1 equals 0, add 1 to both sides, n equals positive 1. So again, 1, 2, 3 solutions to a third degree equation. Okay, now I want to look at some problems that the author refers to as lookalike. And problem A is x squared plus 4x plus 21. Problem B is x squared plus 4x plus 21. I wrote this incorrectly, my bad. It's a minus there. Yeah, okay. So minus 21 and minus 21 equals 0. Okay, now part A, problem A, is not an equation. You cannot set it equal to 0 and solve it. All you can do is factor it. Okay, so to factor it, we've got an x and an x. We've got a product that's negative 21 and a sum that's 4. How about 7 and negative 3? So plus 7 minus 3. That is as far as you can go because it's not an equation. It's just a trinomial. Now, part B, however, is an equation. It is set equal to 0. So we're going to get the same factors because it's the same trinomial. Now we can take each factor that contains a variable, set it equal to 0, and solve it. But I've seen this happen a lot on tests. Students will take a polynomial and they'll factor it, and then they'll just out of the blue set it equal to 0 and solve it. Or students will take an equation, they'll factor it, but then they'll stop and they won't solve it. So pay close attention to what it's asking you to do. You can't solve an expression. You can only solve an equation. This is just an expression. All right. Well, that's all I've got for you today. So I will be back at 1:15 with an office hour, should you have need of me. And I'm going to go ahead and stop the recording.